Um, okay, so now we're going to create our own deformation inside the vertex shader. So we're going to create a new base, and we're going to call it bend deformer. So just to, as a recap, so it's kind of how to create this kind of bendy motion just inside the shader.
Did you draw the
Sorry?
Did you draw the models for those anemones too, or did
Yeah, the models are done in a separate modeling program, imported and deformed and shaded inside of TouchDesigner. Yeah. So you can copy like the kind of the render, the geo, the cam, and the light from the previous. Or you can just copy the whole thing and like paste it again. So the geo, what we're gonna do, so I'm inside the geo1 container right now. And I'm gonna, in stop, I'm gonna create a tube. I'm gonna change a few things. So if you click on the viewer and then you click W, you get like a little 3D viewer here, and you can show the wireframe. And what I want is to make it a little thinner, like 0.2. And then I'm gonna only have maybe 20 columns. And I'm gonna offset it by 0.5 so it sits on 0.
sorry, can you look at the
Yeah, it's not a big deal if you don't have the. Yeah, I don't need that. And then we're gonna turn on both the display and the render. And we're gonna go up again. So now we're gonna create.
Can you go back to
Sure.
what else did you have in this 16? Did you have a null in there too?
No, I didn't do it this time, but you should in general. But it was. You have to make sure that these two are on, the render and display. So then I created a standard Fong material. And I'm just gonna output with the default options. And then I'm gonna assign this new material to the tube. So now what we're gonna do is bend the geometry and a kind of easy way to do it. So if you imagine, okay, that's like my geometry, and like I have a, so I'm just doing a line. So what I want is, I want to kind of do this. Yeah. Okay. So if I were to just apply the same rotation to every point, then I would get this. I'm going to get rid of this one. So what I want is to kind of have I want the last point to have more rotation than the bottom point, so it does something like this. So this is like if all the points. So for this, what we're going to do is we're going to do a rotation, but then based on the height of the point, we're going to limit it. So the first thing is how do I rotate points inside of my shader? So if you, so now it becomes a little easier if you go in the help and also as the GLSL material. So there are some built-in functions that TouchDesigner provide, and one is called TD rotate on axis, and it takes an axis and an angle. So that's what we're going to use. So I'm going to copy paste it for now.
Sorry, that, what page were you on in the help? Was it not GLSL material?
It's right a GLSL material. Mm-hmm. It's in command function.
Oh, right, okay, gotcha, thank you. Are you running that?
So we're going to do this right at the beginning. So I'm going to create a new vector 3, and I'm create new position. And I'm going to say it's equal to TD rotate on axis. Multiply by P. And so at the moment, we're going to give it a small rotation because they're in radians. And we're going to say it's going to be the z-axis. So it's going to be 0, 0, 1. And in the next line, instead of using P, we're going to use our new position. So I'm going to use the geometry viewer to show you what this looks like. So now I get, you can see it's rotating. So I'm going to create a uniform to kind of be able to animate the amount of rotation. So it's going to be uniform float u rotation z. And then I'm gonna replace it here. So now we're back to 0 because we need to kind of define the uniform.
Can you slow down real quick?
Yeah, I'm gonna put it here so it's easier to. Maybe I'll do this just a little smaller, like this.
Where do you have P defined?
So P is built in. It comes from the. So P is the positions of the vertices coming from the subs, from the mesh. If you go all the way up, I think P.
Yeah, I was using lowercase p by accident.
Oh yeah. Oh yeah, so you have this section called working with geometry attributes. And so this is already in the shader. You don't need to type it. So you have in vec3 p, so that's why it's p and the normal is n. So that's already defined for you. And cd for the color, and uv for the coordinates, texture coordinates. Okay. Yeah, I'm gonna close this. Oops. So this time we already have a bunch of uniform already defined, which are the ones that are used for the Phong lighting. So to kind of keep things tidy, I tend to use the vectors 2 page. And so here I'm gonna type U rotation Z. And now you can see that when I do this, it's doing a rotation around Z. So just a quick note on matrices transformation. So TD rotate on axis. What this thing does is it returns mat 3. So a mat 3 is like a 3 by 3 matrix. And so it's kind of like a property. You can define transformation using matrices. So you have like a matrix for rotation, a matrix for scaling. And if you use 4 by 4 matrices, you can also use matrices for translations. And then you can just multiply your vector with the matrix, and it's going to apply the transformation to it. So that's what is going on here. And it's always going to be the vector on the right side and the matrix on the left side. And if we want to combine multiple rotation, we can just multiply multiple matrices together before the point. Sorry?
Did you have to type in U rotation Z?
I did.
So if you click on load, it doesn't do it. The uniform.
It'll show up in vector 1.
Show up in vector 1.
Yeah, I think it shows up just before, just below U shininess. It's going to use the first slot available. Because you can't overwrite P, so I can't say P equal my new P position. You have to create a new variable.
Now we want to do that for every point as it goes up.
So now you want to have like a different rotation for every point.
And again, every point runs the main.
Yeah, every point runs the same code, and all it knows it's just, oh, I'm a point. And
Is there any?
so one thing I did is my tube. It's 1 unit high. So the y coordinate of the tube goes from 0 to 1. So you can just use that, and it's just going to work.
You can also use the point index as well, right? If the points are organized in something.
Yeah, but for this, since it's a tube,
Yeah, it's a tube.
you would get different values, which can be cool. I mean, it could be like...
Yeah, gotcha.
But the other thing is I could also create a custom attribute and like give it the populated the way I want, and I could use that. Like, let's say I want my geometry to like be bigger. Well, I could like kind of do it within 0 and 1, save a new attribute, and then scale it, but still use my older attributes, and that would work.
What's the difference between like vector 1 and vector 2?
There's no difference. It's just more slots.
So maybe I can put this and
Yes,
as well.
it's the same.
Okay.
So one thing you want to make sure you don't do is if you have, if you define multiple times the same uniform, because then it's going to use the first value, and that just gets confusing. I know sometimes it happens to me, like I think when I have like many uniforms, I'm going to like type it again, and then it's just going to be confusing. So yeah, so now what we want to do is we're just going to multiply this by p point y, and now it's going to bend. So now you get this.
Oh, that's how you did that.
But now we're
Like a creature.
so two things to note. So one is that all the code for each vertex is executed in parallel, so you can have really dense geometry, and it's still going to be really fast. Whereas if you do it using a sub on the CPU, like I think there is a band sub, for example. If you were to do that on the CPU, so the CPU is going to loop over every point and does the calculation. I mean, CPUs are really fast, so you can still like do a lot of points, but if you want like a whole forest, at some point you're going to be stuck. And the other interesting thing, which is what we're going to do next, is now what we're going to do, we're going to use instancing to kind of create a lot of these different tubes, and each one can have like a different band, and you can animate that using textures, for example. So people who are familiar with instancing, so you know you can kind of control the rotation for every instance. So we're going to do the same, but using this extra bit of code. So it's like instead of the whole instance having one rotation, each instance is going to have like a different band. So I'm gonna copy this whole base for the next step, and I'm gonna rename it band deformer instances. So now if you're using a text editor, you maybe want to close things so you don't mix things. I'm just going to tidy things. So now I'm in the instances folder. So what I'm going to do is create a grid of these little tubes. So I'm going to create a grid sub. The grid sub, I'm going to change its orientation to ZX. So it's flat. So if it seems like it's disappearing, it's just because it's flat, so it's still here. I'm going to put down a null. I'm gonna rename the null to chop.
To chop, you said?
Yeah. And then I'm gonna use a chop, a sub 2. And I'm gonna point it. So
What's the to chop?
so it's a null I just renamed. Yeah. And so this is gonna give us. So each sample has like the coordinate of one of the points in my grid. And then I'm gonna add a null chop, and I'm gonna call that instances. Oh, the grid, I set it to zexplain. The grid? The grid. So it's just like flat and not facing you. Yeah. And so now what I can do is I'm going to select the geo one. I'm going to go to the instance tab and turn on instancing.
That's for the specific geo?
Yeah, it's for geo 1. And I'm going to drag instances in that field. And then you can, so then you have to specify which channels are the X translation, the Y translation, and the Z translation. So I'm just gonna do TX, TZ, TY.
Oh my god.
So now it's really dense,
You
so
have to increase the size of the grid. And
yeah.
Make the grid over.
So I'm gonna
Or
increase the,
smaller too.
Oh my god.
and I'm gonna pull the camera back. But yeah. The other thing I'm gonna do is just do it like 10 by 10 because we don't need that many for.
How did you change the spacing of the instances? I'm sorry.
So I made the grid bigger, so it's 6 by 6,
Size, okay.
and also I reduced the number of rows and columns. So we have only 10 by 10 instead of 20 by 20.
It's still a lot.
So now we have 100. So we have 100, and I'm gonna pull the camera back a little and up.
Are you doing that using the target?
Yeah. So I get like this, maybe a.
Oh, do you have to like rotate it?
Yeah, as long as you can like see what you're doing, it doesn't matter too much exactly what the camera is. And so now I can do this, and it's they all do the same, so it's kind of boring. Yeah, I think I'm gonna make my tubes a little thinner, so I'm gonna do 0.1 radius. And I'm gonna check the end caps, which like adds a little polygon at the top. So it looks like this. And I'm gonna raise the light a little, so the lighting is just a little nicer. And to the right.
You said you made your tubes a little thinner?
Yeah. More like blades of grass or something.
I think you just adjust the radius
Yeah, I
Yeah,
just,
yeah.
yeah. 0.1 instead of 0.2. So now what we're going to do is we're going to generate a bunch of different values for all the, for each instance. We want them to be coherent in space, so we're going to use a noise chop. We're going to do it a few different ways. So first we're going to use a noise chop. So the noise chop, if you connect positions to the first input, then it's going to use the 3D position to kind of return the noise values at this position. So now we have 100 different values.
Oh, you're using just a chop.
And now what I'm going to do is I'm going to attach a null. And I'm going to say null air rotations. And so now what we want is inside the vertex shader, we want to each instance to read one sample from this. And so the way we do it is we're going to use what is called a sampler buffer, which is basically an array. And then using the ID from each instance, which is the number of the instance, we can reference an index, a specific sample in this array. So if you go to the Phone1 GLSL and you select the Arrays 1 tab, we're going to create a new uniform and call it S rotations. So it's just one value because we're only doing the rotation in Z. So we leave it at float. And chop, I'm going to drag the null rotations. And one important step is to switch the array type from uniform array to texture buffer. So the uniform name, that's the name we're going to use inside the code. The chop is the name of the chop in our TouchDesigner network. And array type, you want texture buffer, because the regular uniform array, I think they're restricted to only 32 values maximum. Texture buffer, you can go like 4,000 or like even bigger. Another way we can reference it inside our vertex shader. So we're going to create a new uniform. And the type is going to be a sampler buffer. And the name is going to be S rotations. Now I'm going to create a variable which I'm going to call instance rotation. It's going to be a float. And this is going to read into the array. And the function we're going to use is TextL fetch. So it's related to texture, except for like a few different things. But the first parameter is going to be the name of the sampler buffers, so S rotations. And the second parameter is going to be the index. And so Touch provides a uniform a function that's going to give you the index number of the instance. And it's td instance ID, parenthesis, and then we close the parenthesis for the function call and compile. And I got an error, so I'm gonna, oh yeah, the narrowing. Yeah, so this thing is TextL fetch. by default is going to return a vector 4. So since we're only interested into a float, we need to do point x. So it gives us only one value.
Can you,
Yep, I'm
I
leaving
just
it.
want to see that, like, the float instance rotation.
So it was the new chop I created that comes after the noise. I'm gonna show again I'm gonna show both the code and the okay, and then the next step is, so we're just going to use this value to and multiply it.
But you know.
And so now,
Okay, that's awesome.
and now you can see they all have different band. Were multiplied, so the rotation angle. So we still use our uniform, which is going to be like a global multiplier. We still use the p.y, which defines like the rotation based on the height of the tube. But then each instance gets a different rotation. And so now I'm gonna make it maybe a little stronger. Okay. And now, so now we can play a bit with the parameter of the noise. So I'm gonna, oops, put this. So now one thing we can do is animate the noise. So I'm just going to do a simple.
In the next line, you multiply it times p1. Oh, did you change?
So now I'm back on the chop, the noise one chop. I'm on the second tab, the transform. And I put this expression, me.time.seconds time 20. And so now it's going to translate the noise, and so it's going to animate the values.
Vincent, how did you get the noise to move?
So in the translate in the ty, I'm putting an expression. So right now I'm doing me.time.seconds, so it means it's going to reset when the timeline resets.
Yeah.
So you see it jumps.
But it's just that.
So if you,
Oh, sorry.
yeah, so just if you don't want it to reset, you can either make your timeline really long. I think I kind of like it because then if you want to debug stuff and like it's always like the same, you know. The other thing you can do is instead of me.time, you can do ABS, capital T, and that's like a time since touch is running, and so it's never going to reset. But if I hit pause, and then I wait a little, and then I hit play, it's going to jump because this absolute time keeps going whether the timeline is playing or not. So I do like to use, for testing me.time. I think just in general, it's back practice to use me.time. You kind of want a separate chop that does the time, so this way you kind of manage it independently from the timeline. Just a quick, easy thing. Some other things we can do with the noise. If we play with the scale, you're gonna see different. So if you do if you do a smaller scale like 0.3, then you're gonna see more like a uniform motion. And
It is still moving, right?
and then a nice thing is that we can do like a lot more. We can do 30 by, I mean, let's see. So now the nice thing is that you can have like a lot. So I'm going to pull back the camera too. So in all those kind of nice Unity and Unreal demo, when they show you the grass swaying in the wing, it's like this kind of techniques, like animation in the Vertex shader, which is like much lighter than if you had to do it otherwise.
Is there an easy way you would get it to bend in the like y direction?
So we can, yeah. So what we did in Z, we can just add another matrix that's going to rotate in the other, in the X direction, and you can use another noise, so you have these two different motion at the same time. So now the thing is when you so now when you have a lot of instances, we're still calculating the rotation on the CPU because we're using a chop. So if I middle click on my noise one, you can see it's taking me 1 millisecond to calculate of those noises. So what we can do is we can either use a noise function inside the shader, or we can also use kind of create a texture, which can be a noise or anything else, and then sample the texture to animate the rotations. I played with the scale of the noise. Is that what you mean? So when the scale is pretty small, it's like so if you drop down a noise stop, it's like easier to visualize. So you can see if you get a small scale, then the kind of variation are like not as crazy as if it's like a really small scale, a really big scale.
What about the replacing the grid with something else?
Yeah. So instead of the grid, I could use. I mean, first I can add a little noise to the grid. So. Tuck.
We're still trying to do it. Stop.
So now it breaks things a little. And what you can also do is you can kind of sample the normal from like the source. So like the base position is kind of oriented based on the surface. Because right now they're all like pointing up, and then we like do this. But if you like put them on like a sphere, like this one will point this way, and this one will point this way, and then they will do like this. So you can do all this. You can like stack deformation basically. So.
Cool. And that's what you did with the with your planet video?
Yeah, the sphere. They're like follow.
To a sphere, it would all still be vertical, right?
With this setup, they would still be vertical.
You'd have to compute the normals or something like that?
So I think maybe, I mean, so when you use instancing, on the page 2 you have these things, rotate to vector XYZ and rotate up XYZ. So you can use that and give it the normal, and it's going to rotate towards the normal. Yeah. So I think you could just use that, and this would work, and you wouldn't have to like do more matrix transformation by hand.
Yeah.
So, but you can also kind of do it yourself inside the shader. Okay.
Can you run back through this example one more time, just like
Which
the overall network, like how everything's...
the net? Yeah, so I have, so this part is just to create the XYZ position. So I'm doing a grid. I convert the point position to these arrays of values, which are the XYZ position, and these are used as the source positions for all the little tubes. And I'm also using these positions to compute a noise for the rotation that's going to be spatially coherent. So you can see it like when you can see it, yeah, when I'm like scaling down. And then, so when you're on the instance tab, you need to turn on instancing, and you point the chub that contains the XYZ coordinate you want to use. But then the noise rotation, since it's a custom thing we're using in a custom way in our shader, this you have to point it on the arrays page. You have to define a new sampler and point the chub, and then you can reference it inside the shader. The thing that's a bit confusing is you have some things that are on the geometry and something that are on the shader. It's like a way to like define like how it works. I mean, what you could do is you could like remove all the instancing attributes from here, and then you could like kind of feed them yourself and do the transformation yourself. But I think as much as possible, you kind of want to reuse what is like in there.
Yeah.
So. So, yeah, everyone got good to this point?
So when you're multiplying times p on the after the rotate on the axis,
Mm-hmm.
what does that mean?
The p dot y, the which part? The
yeah, your line 29.
oh this line.
Yeah, line 29. What is that? What are you doing there? Yeah.
So what that means is apply this rotation to the point. And that's just the way matrix transformation work. You multiply, so you have your vector on the right, and on the left you have your matrix, and it's going to apply the transformation that's contained in the matrix to the point.
So P here is provided by TouchDesigner.
Yes.
Each individual vertex.
Yes.
Each geometry.
Yep.
And it has 3.
But P is the same for every instance. It's different for each vertex, but each instance uses the same base model.
Gotcha.
And it has 3 values. P holds 3 values, X, Y, Z.
Yep. P is vector 3. So in case you missed it, at the beginning of write GLSL material, you have working with geometry attribute. And so you see you have in vec3p vertex position, in vec3n normal. Oh yeah, so one thing important I forgot, you can get away with it because we're not doing any crazy deformation. But so right now we're not updating the normal, so the lighting is wrong because we're bending, but the normal still points to the same position. So the nice thing is that any matrix transformation, you can apply both to position but also to vectors. So I can just take the same matrix and multiply the normal with it, and I'm going to get the correct lighting. So that's going to be our next step.
And another question, and the output of TD rotation on the axis is a vector 3.
It's a matrix. It's a matrix 3.
Matrix 3, right?
Yeah.
And so, yeah, the first ones are being, so
So if you
1 through 3 is being multiplied times 1 through 3p.
yeah, if you've never done matrix math, it's so the way you do it is there are like different conventions, but so the identity matrix, it's a matrix that doesn't do anything. So it's 1, 1, 1, and 0, 0, 0, 0, 0, 0. And my vector is oops. And I'm gonna write my vector as a column, and it's gonna be x, y. I should just do caps. Sorry. X, y, z. And so it's basically you sum. Oh, thank you. So it's going to be x times 1 plus 0 times y plus, so the result, so when you multiply these two, the result, it's x times 1 plus 0 times plus 0 times.
Oh, gotcha. Which is why it's the identity, because it keeps it the same.
Yeah, because it's gonna keep.
So to give you like 1x.
So equal x, and here it's gonna be x times 0 plus y dot 1 plus z dot. So plus z. So you get. So when you multiply this by this, it doesn't change anything. So that's why it's the identity.
Right. That's when you rotate is when you start assigning different.
Yeah. So when you rotate, so scaling factor is going to be scaling is just multiplying the points. So if you want to scale your geometry, you just like replace one by something else. And rotation is going to be the other values. And if you want to do translation, so you're going to use 4 by 4 matrix, and the vector you're going to add a 1 at the end.
For W?
For, yeah. And then when you do the multiplication, it's going to add what the translation is stored like on the as a column. It's going to.
So the translation is what W stands for.
So
X, Y, Z.
it stands for different things, because it stands for that, but also in the pipeline when OpenGL does the projection, it's gonna do something which is called clip coordinates, and it's kind of defined. It has to do with the depth towards the camera, so that it does multiple things. But so yeah, the nice thing is you don't really need to understand all this, and I mean it's nice to understand it a little, but you don't need to do it by hand. You just need to know. I need a 3 by 3 matrix to multiply my vector. If you want if you type rotation matrix, Wikipedia, you're gonna. So in 2D it's this. I think they have it in 3D too. Yeah. So here you have it. So rotation around x, it's gonna be cos theta minus this coefficient. So the TD rotates on axis. What it does is kind of create this based on the axis you give him.
So that and TD rotate on vector, both just do that vector math for you.
So the TD rotate on axis creates the matrix, and then the multiply, it's doing the multiplication between the two, the matrix and the point. So yeah, so to fix the lighting, instead of we're gonna store the result of TD rotate on axis in a matrix, and then we can use it twice, and we don't have to compute it twice. So I'm going to declare a new matrix 3, and I'm going to call it Z rotation, I don't know, Z rotation matrix, and I'm going to say it's all this, semicolon, and now I'm just going to replace it here. So this doesn't change anything. And now if you scroll down a little, you're going to see N. And you can just multiply before the N. Yeah, so the difference is like pretty subtle. Just if I take it off. Yeah, you can see the lighting change a bit, but since we're not doing crazy deformation, you could get away without doing it. Also, sometimes you don't want realistic lighting as an effect, so you don't. Yeah. What I separated is because now I also apply it to the normal here, and that gives you correct lighting because it's also going to rotate the normal. Otherwise, the normal doesn't get automatically updated. And so I'm storing it into an intermediate matrix, so you don't calculate it twice. You only need to calculate it once, and you can multiply both the point position and the normal. Yeah, matrix is a 3 by 3. It's 9 different values. A vector is only 3 values. Yeah, one thing I also mentioned is Vertex Noise. So I feel a lot of people cover it online. So I'm listing a few resources if you want to look into that. So Marcus Ekman did a good introduction to GLSL talk during the Berlin Summit. And so he covers how to do how to use a texture to kind of deform the vertex. And also Matthew Ragan has this workshop called Make Some Noise, which is all about using noise to deform. I'm going to share this. So I thought I would do the band deformer instead. It was like something different.